Hi, and thanks for watching this video. My name is Matt Huberty, and I've created a program in Visual Studio which matches and meets the specifications as outlined in the midterm project. So here's a demonstration of how my program works, and I'm going to go ahead and resize the screen so that you may see it and follow along on this one document as I go through each part of the program specification. So if we look at the specifications, the first step is that a shape hierarchy has to be implemented. And if you look here in the project, you'll see that sure enough, there is a shape hierarchy. The shape is one of the main classes that I made, a base class that I made for the program. You can see that it also carries with it some hidden and encapsulated instance variables. Furthermore, it also uses a few properties that are public to all shapes, such as the type. Moreover, it implements some overridable functions and properties, as we'll see later, to be used for spheres, squares, cubes, and circles. So let me go ahead and run the program here, and we'll continue to follow along this Word document. The second part sort of already covered, which will be demonstrated later through the use of the program and through the running and execution of the program. The third implementation and the third requirement of the midterm project is to implement a file menu, which is what I've done here. I've also entered and allowed the user to enter shape data. You'll notice too that this form is modeless, which allows the user to bounce back and forth between this parent form, the main form, and entering data. The entering of the shape data also should allow the user to select which shape he or she wants to create, which is something that I've done here. So he can create a square, or he or she could create a circle, and you'll notice too that the side length disappears if the user chooses circle. The same thing goes with cube and sphere. Only radius is important for spheres and circles, and only side length is important for cubes and squares. So imagine if you were the user, you can create a new shape, which is what I've done here. The side length is 6 for a new cube, and you get a confirmation window displaying that a new cube has been created. Furthermore, it tells the user what numbered shape that is, how many shapes that they've created so far. So I'll go ahead and create a few more, and I'll get more confirmation. And I'll create a circle with a radius of 8. And lastly, let's just go ahead and create a sphere with a radius of 9. And we can click OK. We can also go back to the specifications. The form should only display the necessary text boxes where input is required. I think you've seen that. It doesn't ask for a radius when creating a cube or a square, for example. This form only allows the user to enter one shape at a time and to close the window when he or she is done. Obviously, my program does that, which I'll show you the close function here in a minute. Let's talk about the display menu function next, just because that seems to be the logical part of the program to look at next. So if you go back here to display, it'll bring up another window where you can display items that have been put into the object array. And you'll notice, of course, too, that when displaying this shape, it tells the user what shape type it is. In this case, it's a cube. The slide length of the cube is 6. The area of the cube is 216, and the shape volume is also 216. You can then just continue to go down and look through the menu, all the shapes that have been created so far. And so far, we've created 4 of them. This is the last one that I created, a sphere with a radius of 9. Its shape area is 1017.88. You'll notice too that the decimal points truncate after 2 decimal points, which is a specification of the project in the program notes. Furthermore, this is also truncated to the second decimal place. The value is rounded. It's a single value, so it gets rounded. Furthermore, another specification in the project is that there should be an error message displayed if there is an empty array cell, which it's doing here. You'll notice that if you want to see what's in cell number 6, it'll just tell you that the storage device is empty at this location. You can also close the form Furthermore, another specification of the project is that you should be able to add and be allowed to enter more shapes and objects, which I've been able to do here. So if we can create another cube with a side length as big as 15, this should be our 5th object, which sure enough it is. Shape number 5 has been created, a cube has been created, confirmation of that. You should be able to go back to display shape data and see that there is now an object in 5, and sure enough we do. We have one, a cube with a side length of 15 and a shape area of 1350 and a volume of 3375. So as you can see that this meets most, really not even most, all of the specifications within the assignment. The option allowed us to see the contents of the shape array at any one time. It's modeless. You can bounce back and forth between windows, which meets the best practices of MDI forms. The form should only display the necessary calculations to each shape. You'll notice that too back here again. If you're looking at a circle, for example, there is no volume to a circle because it's two-dimensional. Furthermore, there's no side length. Circles have radii, not sides. Therefore, these two text boxes and labels, the label is still there, but the text box and the text display box has actually been deleted and made invisible. Let me just jump to this for a second. The help menu you can see here, there is a help menu for the program, which you can look at and see. I've named the program 2D or 3D, you choose. Recorded my name as the software engineer and the version and the date that the program was last modified. Furthermore, if you go back, you can now see the specifications of the save as functions have been met. So why don't I go ahead and display those? You know what, actually, why don't I do one more thing before I do that? Why don't I go ahead and add in a few more functions here to try and create the 11th shape object, which is not allowed per program specifications. So I just created the 6th object. Let's go ahead and do these real fast. Now this should be the 7th and the 8th. Let's make that 8. And now object number 9 and object number 10 we should be allowed to create. Let's make a square, a real big square, side length of 20. And now let's go ahead and try and make our 11th object, side length of a cube. Sure enough, an error displays an object in a shape is not created at all, and it gives us an error message. And so now that we've created 10 objects, I'm going to go ahead and close this window. We can see that all 10 are here, and you can scroll through every one of them at a time. Furthermore, you can go back and look at the save as function, which opens up a save file as dialog box, which I'll just go ahead and call this new version 3. As you can see, I've already done some testing on the program, and it allows me to go ahead and create a text file of all the 10 shape objects that I just created. Furthermore, per program specifications and guidelines, a confirmation window has been displayed. Furthermore, if we go to the file that I just opened up and created, which is this one here, we can open it and see in Notepad that all of the program specifications once again have been met, and we have our 10 objects here. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, sure enough, they're all there. I went ahead and made the executive decision to go ahead and just separate all the data by commas and spaces. These specifications didn't really specify and be more specific about how this information was to be entered, but the one part of the specifications did call for each object and shape to be on its own separate line. So in other words, this is the first shaped object, this is the second, this is the third, etc. There weren't more explicit instructions about how the shape objects were to be saved in the text file, so I just went ahead and did it this way. And so as you can see, the text file has been created, so that function is obviously working. And lastly, we can clear the shapes container. The clear function should empty the object array per specifications. All open forms with the exception of the main form should be closed after objects have been deleted out of the object array. And a confirmation message should display after the object array has been deleted. And sure enough, if I go ahead and open up some more file or windows here to enter shapes or to display them here on the form, we should see that after we clear out the object array, that all of these forms right here in the background should close. And sure enough, they do. A confirmation window per specifications has been displayed. All of the shape objects in the object array have also been deleted. And those background windows that you just saw a few seconds ago have also been deleted. So as you can see, the specifications of the clear function have been accomplished. And I think if you go back and look at this, you'll see that all the specifications to the Save As file dialog box, those specifications have been met. I think the one that I forgot to mention a few seconds ago in the video was that the Save As function should open a Windows Save As dialog box. Here's the key: pre-filtered to show only .text file types, and sure enough, we have that. Furthermore, we should be able to see now what's in the object array, and it should be nothing because we just cleared it, right? And sure enough, we see that the object array itself is empty. So I'll go ahead and close out of this. And then if I want to go ahead and save another file and save the object information to yet another file and call this version 4, as you can see, it's already been pre-filtered to .text files. It'll display an error again that says there were no shape objects saved to the file. Once again, per program specifications and guidelines, there was no information saved to the .text file. And so that kind of wraps up the implementation demonstration of the program and what it's supposed to do. I'll go on to point out in 60 more seconds here all the object-oriented programming guidelines, the specifications that have been met. I've used inheritance within the program, and I've used a base class called shapes. All methods do work on the base shape class. I implemented overloaded operators inside of some of the other classes, such as the cube function, which returns a value called volume, for example, on this public function. It's been overwritten, and I've used the concept of overloading a function inside of cube, for example, to display the volume of a cube by using this formula and returning its value. Furthermore, I think we've already looked at part D. The blank file was created and the error message was displayed. E was covered. A user is not allowed to enter more than 10 shapes at a time. Oh, I guess one more thing I should show you is that the user is not allowed to enter invalid data. So they can't enter negative values for radii, negative values for side lengths, for example. And that I think is the last part that I want to show you, because I think if you'll go back in the video or look at the program itself, you'll see that specifications for GH and I have been met. So I'll just go ahead and show you one more time that if a user wants to enter negative values for side lengths, for example, he will be met with very much problems with his storage abilities. Furthermore, you can't enter in words that are totally invalid. So that ends the project. Please contact me if you have any questions. Thanks for watching.